Well, here is the Shannon wiener index formula. It is represented by the H, and the S stands for the total number of species, and Pi is the proportion of each species in the community. So this Ln stands for natural log. So it is natural log of Pi. And we should not forget this negative sign. To understand the application of the Shannon wiener index, so let us discuss an example. So this is the list of species in the site A, and there are 11 total species. So it means the species richness is 11, and these are the number of species present in this community. So to find out the Shannon wiener index of this locality, we need to first calculate Pi. Pi. So as you know, the Pi is the proportion of each species in that community. We need to find out the proportion. So we have to add this value. So this is 483. The total number of species 483. So now find out the proportions of species. 125 divided by, so 483 is fixed in each of the calculations. So we put $sign here and here. So now we can copy this formula to the remaining cells to obtain the fractions of each species in the community. So now we will find out this natural logarithm of Pi, that is ln Pi. Okay, now we can copy this formula to the remaining cells to obtain the respective values. So now we need to multiply this value by this value. So this multiplied by this. So it is again Pi multiplied by this. Let's copy this formula to the remaining cells. Now we have calculated this part. Now we have to add the whole values to obtain the summation of Pi, natural log Pi. So let us add this value. It is minus 2.067. So, and this value, I already have told you that don't forget this negative sign. So, this value has got the negative sign already. So that is why we multiply this value with -1 like this. This is the final result of the calculations, and this is the Shannon-Wiener index of the site A of these communities. So that is how the Shannon-Wiener index is calculated using the Excel. But as you know, the Shannon-Wiener index is influenced by the species richness and the species evenness. So this value is changed if the two of these factors are changed. If the number of species are changed, then this value would obviously change. But what if the species evenness is changed? To understand this point, let us take the example of site B. In the site B, in this locality, the number of species are different, but there is same number of species. That means the species richness is the same, that is 11, and the species evenness is different because the numbers of species are different, but the total number of species are same. It is 483 and 483. So let us again find the index. Now, although both the sites have same numbers, total numbers of individuals, the biodiversity index is different because here the species evenness is different. So that is how the biodiversity of the two sites compared using the diversity index. But this value is sometimes not understandable because it is based on the log value, natural log value. So ecologists usually convert this value using exponential to get a value related to the numbers of species. So let us convert this value using exponential. So it is approximate the 8. So this value is called effective number of species. So this is nothing but the diversity as the number. So this value is expressed in terms of number of species. So this is nothing but the diversity as the number of equally abundant species that would produce the same Shannon-Wiener index. That means The diversity equivalent to approximately 8 equally common species would produce the same diversity index. Although we have 11 different species, the 8 equally common species would produce the same diversity index, that is 2.067. So ecologists usually use this value to evaluate the status of biodiversity in particular uh, study area.
Shannon-Wiener index is influenced by the species richness and evenness of the distribution, that is, the presence of dominant and rare species. So it is sensitive to even a small change in both the factors, and it is popular and widely used to determine the state of the ecosystem.